हमारा टॉपिक है एंटीबायोटिक्स। और एंटीबायोटिक्स में भी हम किस एंटीबायोटिक्स की बात करने वाले हैं? पेनिसिलिन एंटीबायोटिक्स के। ठीक है, हमारी बॉडी में कितने टाइप्स के बैक्टीरियाज होते हैं, यानी टोटल कितने टाइप्स ऑफ बैक्टीरियाज होते हैं? मेनली देर आर टू टाइप्स ऑफ बैक्टीरिया विच आर ग्राम पॉजिटिव बैक्टीरिया एंड ग्राम नेगेटिव बैक्टीरिया। ठीक है, अभी मेरे को ये बताओ कि ग्राम पॉजिटिव बैक्टीरिया में और ग्राम नेगेटिव बैक्टीरिया में डिफरेंसेस क्या है स्ट्रक्चरल वाइज। मैं आपको अभी दिखाता हूँ। स्ट्रक्चरल वाइज ये हमारा आ गया साइटोप्लाज्म। ठीक है, ये हमारे क्या आ गई? शुगर ब्रिजेस। ये हमारा क्या हो गया? शुगर ब्रिजेस। और ये एक दूसरे से कनेक्टेड होते हैं किससे? पेप्टाइड ब्रिजेस के साथ। ये एक दूसरे से कनेक्टेड होते हैं किसके साथ? ये हमारा कनेक्टेड होता है पेप्टाइड ब्रिजेस के साथ। ये हमारा क्या है? साइटोप्लाज्म। ये क्या आ गए? हमारे पेप्टाइड ब्रिजेस। और ये हमारे क्या आ गए? शुगर बैकबोन। यानी ग्राम पॉजिटिव बैक्टीरिया और ग्राम नेगेटिव बैक्टीरिया। ठीक है, ये दोनों की सेल वॉल किससे बनी हुई होती है? शुगर ब्रिजेस। और शुगर को हम क्या बोलते हैं? ग्लाइकन। शुगर को हम क्या बोलते हैं? ग्लाइकन। ठीक है, तो इसका हम ना ये ग्राम पॉजिटिव बैक्टीरिया की सेल वॉल और ग्राम नेगेटिव बैक्टीरिया की सेल वॉल दोनों किस चीज से बनी होती है? पेप्टाइडो ग्लाइकन। ठीक है, अभी यहाँ पे एक मेन कैरेक्टरिस्टिक फीचर है, ये हमारा क्या है? ग्राम पॉजिटिव बैक्टीरिया। अभी इसके ऊपर मैं एक और लेयर बना देता हूँ। सॉरी, ये उसके ऊपर मैंने एक और लेयर बना दी। ये साइटोप्लाज्म हो गया, ये हमारे क्या हो गए? ब्रिजेस हो गए, शुगर ब्रिजेस। और ये क्या, शुगर ब्रिजेस को एक दूसरे के साथ कनेक्ट करने वाले क्या हो गए? हमारे पेप्टाइड ब्रिजेस। ठीक है, तो अभी इसके ऊपर ये मैंने लेयर बना दी, ये क्या हो गए? आउटर मेम्ब्रेन। आउटर मेम्ब्रेन इज द की फीचर ऑफ द ग्राम नेगेटिव बैक्टीरिया। In gram positive bacteria there is no outer membrane. So, some drugs which are useful for the gram positive bacteria, which are not useful for the gram negative bacteria. Why? Because of the outer layer. In gram positive bacteria, we don't have outer layer, while in gram negative bacteria, we have outer layer. So that drugs are not going to be used for the same the gram negative bacteria. ठीक है, मैं अभी आपको पहले बेसिक से शुरू करते हैं, फिर हम डीप में जाते हैं। ठीक है, bacteria are of two types in our body. Sorry, in our environment. Gram positive bacteria and gram negative bacteria, not in our body, in environment. Okay. So what are the difference between the gram positive and gram negative bacteria? The main difference, the gram negative bacteria have outer membrane and gram positive bacteria doesn't have outer membrane. So the drugs which are going to be used on gram negative bacteria, which are not going to be used for gram positive bacteria, and the drugs which are going to be used for gram positive bacteria which are not going to be used for gram negative bacteria because of the outer layer. Okay, in gram positive bacteria we are usually considering the example of staphylococcus. In gram negative bacteria we are usually going to be discuss the example of E. coli. Okay, the huge difference in the cell wall of gram positive bacteria and gram negative bacteria, that the reason the drugs which is used for gram positive bacteria will not affect the gram negative bacteria. Why? Because of the outer membrane. The gram positive bacteria cell wall has two components, the sugar backbones, which are going discussed here. This is what a sugar backbone. Okay, and made up of sugar is always made of what? Obvious, it's made up of carbohydrates, and this carbo and sugar backbone were cross linked with each other with the help of peptide bond. This is the blue is what? A peptide bond. Okay, the sugar is also called as glycan. So the whole structure, what we call peptidoglycan. Okay, so how many molecules of peptidoglycan make the cell wall? Only one molecule. Only one molecule makes the one molecule of peptidoglycan makes the whole cell wall. Huh, only one molecule. Okay, in gram negative, what we have? Outer membrane. Okay, keep in mind. See, this is the outer membrane. This is the cytoplasm. This is the cytoplasm, plasma membrane. But this green outer layer structure is not present in the gram-positive bacteria. Okay, the difference, the cell wall in gram-positive is thicker and the cell wall is thinner. The penicillin G is more effective in gram-positive bacteria compared to the gram-negative bacteria. Why? We are just going to be discussed very soon. Okay, अभी हमारे मेन टॉपिक पे आ जाता है. व्हाट विल डू द पेनिसिलिन. पेनिसिलिन क्या करता है? बेसिकली जो सेल वॉल का डिस्ट्रप्शन है, सेल वॉल का जो सिंथेसिस है, वो स्टॉप कर देता है. या उसको हम अदर वे में भी बोल सकते हैं कि जो बैक्टीरिया है उसकी सेल वॉल को डिस्टर्ब कर देता है. वैसे कौन सी ड्रग है? वैंकोमाइसिन हो गया, साइक्लोसिरिन हो गया, फिर बीटा लैक्टम्स के ग्रुप की सम ड्रग्स है, जैसे पेनिसिलिन हो गई, फिर हमारे पास एजिथ्रोनोमा हो गया. ऐसी बहुत सारी ड्रग्स है. वो क्या करती है? पेनिसिलिन की जो सेल वॉल है उसका उसके सेल वॉल को डिस्टर्ब कर देता है. ठीक है, उसका सेल वॉल को क्या कर देता है? डिस्टर्ब कर देता है. A group of drug which inhibit the synthesis of cell wall. Which are type of drug? साइक्लोस्पिरिन हो गया, वैंकोमाइसिन हो गया, फिर बीटा लैक्टम ग्रुप्स के एंटीबायोटिक्स हो गए जैसे पेनिसिलिन हो गया, एजिथ्रोनोमा हो गया, सेफालोस्पोरिन हो गया, कार्बापेनेजमाइंस हो गया, बैक्टीरियानिक हो गया. बहुत सारे ड्रग्स है. वो क्या करते हैं? इन्हें डिस्टर्ब कर देती है क्या? सेल वॉल के सिंथेसिस को, या सेल वॉल के सिंथेसिस को बैक्टीरिया के. ठीक है, हमारे पास मेनली कितने टाइप के बैक्टीरिया होते हैं? ग्राम पॉजिटिव बैक्टीरिया, ग्राम नेगेटिव बैक्टीरिया. Why the drugs which are going to be used on gram positive bacteria which will not affect on gram negative bacteria? Because of the outer membrane which were present in gram negative bacteria. Okay, and the drugs which are going to be used in gram negative bacteria, which were not going to be used on gram positive bacteria because they don't have the outer membrane. Okay, so here, see, in gram positive bacteria, there is no outer membrane. So that structure is porous, means the drugs can easily come from outside and easily go into the cell. On the cytoplasm, there is some receptors of this drug is going to be present. So they come and bind on that, on target proteins, and they disrupt the cell wall on the outer membrane of the cytoplasm. These receptors or the target proteins are be present, so the drug came and bind with them and they disrupt the cell wall. But what will going to be happen in the drug of in gram negative bacteria? Because they have the outer membrane, so they can't cross, so they came and just reflected back. So what will going to be happen? Let's see. Okay, before that, I would like to discuss the structure of penicillin. See, this is the penicillin. This is the penicillin ring. With penicillin ring, this is the beta lactam ring, and beta lactam ring. And with beta lactam ring, this is the R group. Okay, so this is the basically the structure of the penicillin molecule of the drug will going to be affected. Okay, what is this? The house-like structure is penicillin. The square-like structure is beta lactam ring, and with beta lactam ring, this is the curly structure. What we called it? R group. Okay. So, outer membrane is the key feature of the gram-negative bacteria. The penicillin binding proteins. See what I told you. Penicillin binding proteins were present on the membrane of the outer membrane of the cytoplasm. The penicillin binding protein were present on the cytoplasmic membrane. If the penicillin and beta lactam have to attack, so they have cross anyhow the membrane. Okay, but but In gram-negative bacteria, they can't, but in gram-positive, they can because they are porous molecule. Okay, the beta-lactam have the special four-ring arrangement, which we see the square-like structure. Okay, and we called it what? Beta-lactam ring. Okay, the beta-lactam ring and interacts with the protein, and this beta-lactam protein will interact with what? The penicillin binding protein or the target protein. So anyhow, the penicillin have to travel into the bacteria to work, and the peptidoglycan is a porous molecule. What is the porous molecule? So that the penicillin can travel easily, and the penicillin binds and shows their actions. Okay. In gram-negative bacteria, also the penicillin binding protein were present, but in the inner means on the same position. But because of the outer membrane, they can't cross it. So anyhow, the penicillin beta-lactam have to go till there, but there is difficulty to cross the outer membrane. Outer membrane is made up of lipids, so that's why outer membrane is made up of lipids. Yeah, so that's why they are not highly porous. So they are not highly porous. Okay, now we will going to be discuss a very beautiful concept. Okay, before that, I would like to discuss this penicillin. How many types of penicillin do we have? There are two types, narrow spectrum and wide spectrum. Today in our lecture, we are going to be discuss with the narrow spectrum. Okay. So the narrow spectrum again is divided into two parts, natural penicillin and very narrow spectrum. Very narrow spectrum. It's not a penicillin. It is a very narrow spectrum. Okay, it's a very narrow spectrum. Wait, let me correct it. Very narrow spectrum. Okay, so natural penicillins. The natural penicillins are of two types, penicillin G and penicillin V. So what we will do, the penicillin G and penicillin V. Okay, so natural penicillin are usually moderately bulky molecules. Okay, so see, this is the outer membrane. Wait. So see, this is the cytoplasm. Let me change the color for you guys. Draw and keep it at red. Okay, red. Mm, And this is the what outer membrane. The red is an outer membrane. Okay. What is the red? Red is an outer membrane. Okay. And some, let me make it blue. And some proteins are present here. What we called this proteins, this channels we called it porins. So the drugs which can came from outer and they can cross this and reach their site of penicillin proteins or target proteins by passing through this channels or this channel what we called it porins. What we called porins. So natural penicillins is moderately bulky, so they are able to cross this protein, go inside to the cell and shows their function. Okay, so the natural penicillins are what moderate spectrum means, they are moderately bulky. So natural penicillin. Okay, so as a result, the natural penicillin is moderately bulky, so it can easily go into the gram-positive bacteria. But in gram-negative bacteria, it will not show its effect. Well, But in some bacteria of gram negative, it will show this effect, which gram negative cocci and syphilis. Gram negative cocci. In gram positive, the penicillin G and penicillin V is more effective in gram positive cocci and gram positive bacilli. And in gram negative bacteria, not in gram bacilli, but yes, in gram negative cocci. It shows its effect. Okay, the natural penicillin have more effect on what? Gram positive cocci, gram positive bacilli, and gram negative cocci, not in gram negative bacilli. And it also shows its effect on syphilis, and it also shows his effect on syphilis. Okay, while we are going to discuss the very narrow spectrum, in very narrow spectrum, they are not able to show is effect. They are what? Anti-staphylococcus bacteria. Why we called it anti-staphylococcus bacteria? Because they are very bulky molecule, so they are not able to cross the sporins. Why they are bulky molecules? See, the staphylococcus bacteria, they are very smart. So they, what they will do, basically they are very smart. They will secrete it the enzyme which which can cut the beta lactam ring, and that enzyme we called it what? Penicillinase or beta lactamase. Okay, the enzyme which secretes the, which cuts the beta lactam ring, we called it beta lactamase enzyme or penicillinase enzyme. Okay, so let's see why we call. So many staphylococcus bacteria have a very produce, not all the staphylococcus bacteria, but many staphylococcus bacteria produces a dangerous molecules and secretes, and they cut what? The beta lactam ring. And what is the function of beta lactam ring? The beta lactam ring, what they will do? The beta lactam ring, they usually bind with the target protein. So if the beta lactam rings cut, they will not show their effect. So what they will do? So the, so now our scientists are very smart as compare. So they, what they will do? They will increases the R group. So the R group folding is increased. See here. So R group is still here, right? So they, what they will do? I'm just overlapping from here. They will increases that, and they overlaps the R group, so that the beta lactamase is only able to cut the beta lactam ring, but R groups cover him, so they will not going to show their function. So that's the reason the very narrow spectrum is only targeted to staphylococcus and shows more effect on staphylococcus compared to other drug. The drug, other drugs which can also show the effect, but the anti-staphylococcus bacteria is the best. They cannot show its. That's why the doctor gave him the anti-staphylococcus name, because they are only going to be work on the staphylococcus, and it's more effective. And in wide spectrum, in next students lecture, we again shows that the staphylococcus bacteria is again smart and how they will going to be inhibited. But today, remember, this is the smart way. Okay, so the R group increases and overlaps and the beta lactam rings, so that the beta lactamase or penicillin enzymes not able to cut the ring. And in this way, we can introduce it, and they, and in very narrow spectrum, the molecule become too bulky. Because of what reason? We increases the R group, so that the molecule become little bit bulky. Okay, wait. The very narrow spectrum, they are also called as anti-staphylococcus penicillin. Why? Because they are have very good function. These drugs have very good functions on the staphylococcus bacteria compared to other drugs. Okay, they are so bulky. Why they are so bulky? Because they increases the R group folding around the beta lactam ring, and they can go only into the staphylococcus bacteria, because the every porins have the different sizes. Say if it is 4 mm, the bacteria can the drugs can pass. This is the 3 mm. So depending upon the porins, so they can only pass into the staphylococcus, and they are failed on gram neg positive bacteria to go. Because why? Because of the porin size. It's okay. And gram negative bacteria, and this penicillin is very large charge group. Why this is very large group? Because from the protection. Okay. The anti-staphylococcus, the drug, what is the methicillin, neficillin, clo, cloxacillin, dicloxacillin, fluxacillin. Okay. The many staphylococcus, why we need a very large R group? Because the many staphylococcus produces the dangerous molecule that secretes and cuts the beta lactam ring, and this molecule break down the penicillin, the enzyme which break down the penicillin, we call it penicillinase or the beta lactamase. The beta lact they cut the beta lactam ring. So that's why the penicillin G and penicillin V are not effective to kill the staphylococcus, because of the why they are not effective, because of the R group chain. In here, R group chain is bigger. There is the R group chain is smaller. Okay, penicillin molecule and this R group wraps around the beta lactam ring and protects them for cutting down. And as a result, the molecules become more bigger and lost the function to act on another. Why they lost? Because of their size, they become bulky. And the very narrow spectrum is resistant to penicillinase. Resistant to penicillinase, and natural penicillin is sensitive to penicillin. Okay, it's but obvious. See, very narrow spectrum. They are resistant to penicillin because they are secreting the penicillinase enzyme. So to form protection, so we require that R large group. So they become this natural penicillin. They are not going to be secreted. So they are sensitive to the penicillin. Okay, now we will come to this page. Okay, the reason some antibiotics were large or bulky, their molecular structure were highly charged. They can pass through its membrane or not. It's not because every see if the bulky molecule is there, so they are not going to affect on the gram positive bacteria like gram positive cocci and all those things. And the staphylococcus like cloxacillin, methicillin will not going to be affect on gram positive cocci because of that because of their porins and gram positive bacteria's charge and all those stuffs. Okay, the gram negative bacteria has some special arrangement to transport the substance through its outer membrane. The special arrangement we called it what? 4 inches through the channels they are passing into the target protein. Okay, so anyone how to go inside, anyhow have to go inside and interact with penicillin binding protein or the target protein. If antibiotic can't pass through the porins, they can't show their effect. If it is a 4 mm structure is there and I'm trying to put the 6 mm drugs, so it will not go, so it will not show its effect. We have to design the drugs and all those things according to that porin size, gram positive and gram negative. The penicillin G is a bulky molecule, so it reaches very easily. So that's why the penicillin G molecules have very less effect. Okay, penicillin G is what? A bulky molecule. So in gram, it's a bulky molecule. So it can't reach it to this gram negative bacteria. So if it can't reach it properly, it will not show its effect. See, if your productive time is morning 4 to 5 a.m., so you will show is your productive at much more. And if you, and after the day completed at 6 o'clock, after 6 your boss comes and tell you to make the videos or anything the ppts, so your productivity is of course lost because you are tired, you are not able to do that properly. So it's the same like a drug. If you are not able to reach at proper time and all, so they will not show us effect. Okay, now we will going to discuss how the penicillin G and penicillin B is going to be work and how it will going to be affected. See, penicillin G, we usually give the intravenously. Why we will give the intravenously? Because this is the first molecule we are going to be discovered. So we are going to will give directly intravenously means inside the veins. Okay, the penicillin V we gives the orally. Why we will give the penicillin V orally? Why we will not give the penicillin G? Let me discuss it. See, basically, because it's a very primitive molecule, okay, and it not only attack the penicillin, see, beta-lactam ring, it's not only affected by penicillinase or beta-lactamase. It can also be affected if you take the drug orally. But obviously, it will go to the stomach. In stomach, what we have? The HCl. The HCl, what we will do? HCl will degrade the beta-lactam ring, and it will not going to show its function, okay, properly. So beta-lactam ring will not going to show its function properly. So now so the scientists, what they will do, they will modify the drug penicillin V. That's why we are able to take it orally. How? See, that is the penicillin structure. Mm, let me keep it in black. See, this is the normal penicillin G structure. What the scientists will do, here the HCl binding site and here the penicillin is binding site. I'm putting here the P and here I am H. H for HCl binding site and P. So what they will scientists do, the little bit increases the size of penicillin V of penicillin V R group. So they covered by the HCl so that the HCl not going to bind on the beta lactam ring. If it will not going to bind on beta lactam ring, the HCl, they will not degrade it. Okay, so the smartly they what they do, they simply increase the little bit size of the R group which covers the HCl from the binding, and so that the penicillin we can will take the orally and we can protect uh, the drug from our intestine will not going to be destroyed by the beta lactam ring, and they are able to going to reach into the cytoplasm properly on the outer membrane of the cytoplasm and bind with the proteins. Okay, where we are. Okay, so because it is a very because it is a very primitive molecule, it is not only attacked by the penicillin or beta lactamase, it also attacked by the HCl. Penicillin G is usually give the intravenously, usually we give the why the penicillin we give uh, orally, because it was been protected by the small r, by the extension of small r group. Okay, we we also have r group which can larger little bit and protect by covering the HCl sites and protect him. It's so messed up. Okay, so in which cases we are giving the penicillin G and penicillin V? The penicillin G is usually given in the children who are susceptible to the rheumatic fever. Okay, the children who are susceptible to the rheumatic fever, we use the penicillin G, and the penicillin V is usually used in the dental infection, mixed anaerobic and aerobic respiration. Okay, while the drugs which were see the drawbacks of the methicillin is what they will shows the kidney failure if you are taking too long times and all this. The nephicillin will also do that the neutropenia and nephritis. See the cloxacillin, dicloxacillin, and floxacillin. What they will do? O indicates you can take it orally. I think so. There is a very less. Drawback of all these drugs, while the methicillin is usually banned in USA because the very high chances of the kidney failure we can see in nefzacillin. Also, the nephritis and neutropenia is also been going to be seen. In Staphylococcus bacteria produces the those enzymes which can basically what they will do. They cut that beta lactam ring, and that's why we have called it anti-staphylococcal penicillin. So to protect them, we usually become wrap the R group around the beta lactam ring. Okay, in tomorrow's lecture, we will going to discuss the wide spectrum. Okay. Before that, I will go into the remember the narrow spectrum and wide spectrum in this way. The killing less narrow means what? The killing the less organism, while the wide spectrum killings the wide variety of the spectrum. So in tomorrow's lecture, we will going to discuss about the wide spectrum. Thank you so much.